In this video, we are going to discuss integration of inverse hyperbolic function involving completing the squares. Okay. Now look at clone example 5 in page 63 in chapter 2 in your handout. The question is evaluate integration of dx over square root of 4x squared minus 24x plus 11. Okay. This question is cloned from example 5. Okay. From example 5 in page 63, the symbol here is positive or plus. But in the clone example, the symbol here I change to minus. Okay. Okay. The solution is as follows. Okay, from numerator, we have constant here. And from denominator, inside square root symbol, we have quadratic expression. So, if we integrate numerator with constant and denominator inside square root symbol is quadratic, so maybe the answer become inverse trigonometric function or inverse hyperbolic function. So if we predict that the answer is inverse trigo function or inverse hyperbolic function, means that we can refer from appendix and we can write in terms of a squared and u squared. Okay, so now we need to write 4x squared minus 24x plus 11 from quadratic function inside square root symbol into the form of a squared and u squared so that we can compare with the given formula in appendix. Okay. So how to write into the form of a squared and u squared? Okay. By using completing the square method. Okay. Okay, so from the quadratic expression inside third symbol, we have 4x squared minus 24x plus 11. Now, we need to write this expression into the form of a squared and u squared by using completing the square. Okay, first step, when we use completing the square, we need to rearrange into the form of ax squared plus bx plus c, means that the first term should be term containing x squared, the second term should be term containing x, and the last term should be constant. And when we compare with the given function inside square root symbol, okay, now the step is done because the first term is term containing x squared, the second term is term containing x, and the last term is constant. So after that, we can jump to example 2. Okay, if the coefficient of x squared not equals to positive 1, then we need to factorize the coefficient of x squared. So now we have coefficient of x squared equals to 4, which is not equals to positive 1. So what should we do? We need to factorize 4 because 4 is coefficient of x squared. So after we factorize 4, okay, so we can write 4 and then bracket x squared minus 6x plus 11 over 4. Why in bracket is this expression? Okay, because when we expand, okay, we multiply 4 times x squared, we get back 4x squared. We multiply 4 times negative 6x, we get back negative 24x. And when we multiply 4 times positive 11 over 4, so we can simplify 4 here, so we get back positive 11. Okay, so we get back the original expression from the third symbol in this question. Okay, okay, now the coefficient of x squared in bracket here is positive 1. Okay, so after that, we need to put bracket squared plus bracket squared minus bracket squared after the term containing x here. Okay, like this. Okay, after the term containing x, we need to write plus bracket squared and minus bracket squared. Okay, and then plus 11 over 4. Okay, the red color is when we put plus bracket squared and minus bracket squared. The blue color is from the above. Okay. Okay, what should we put inside bracket? Okay, so inside bracket squared, we must put half times coefficient of x. Okay, the coefficient of x is negative 6 here. So when half times negative 6, we get negative 3 here. Okay. And after that, the first three terms we need to write into the form of bracket squared. And the remaining term we simplify. Okay. So the first three terms, 1, 2, 3. Okay. The first three terms we write into the form of bracket squared. And the remaining term here, we need to simplify. You can use calculator here. Okay. So after that, we have 4 outside bracket. So the first three term, 1, 2, 3, we write into the form of bracket squared here. Okay. So we just choose term containing x squared. So we have x squared and negative 3 squared. So we put x here and negative 3 here inside bracket. Negative sign here comes from negative 6. Okay, coefficient of x is negative 6. So when we multiply by half, we have negative 3. So the symbol inside bracket should be minus here. Okay. Okay, and after that, the remaining term, we need to simplify. Okay. Okay, we cannot multiply negative and negative here. Okay. What should we do is, we need to simplify negative 3 squared first. Okay. So negative 3 squared, when we simplify, we have positive 9. So means that negative 9 plus 11 over 4. So we have negative 25 over 4. Okay. Okay, after that, we can write x minus 3 bracket squared minus, and from constant negative 25 over 4, we can write in terms of bracket squared or in terms of a squared because this is constant. Yeah. So we have minus 5 over 2 bracket squared because when we simplify 5 squared, we get back 25. And when we simplify 2 squared, we get back 4. Okay? Okay. The next step, we need to write the quadratic function inside search symbol in terms of 4 bracket x minus 3 squared minus 5 over 2 bracket squared. Okay, this comes from computing the square, okay, which is equivalent to 4x squared minus 24x plus 11. Okay. Okay, and after that, we can move out constant 4 here. Okay, constant 4 here inside search symbol or inside square root symbol and in denominator. So when we move out constant 4, okay, from integration sign, okay, we need to move out square root of 4 also. Okay, we need to move out square root symbol also. So square root of 4 is 2 and 1 over 2 here comes from fraction here. Okay, because we have 4 in denominator. Okay, so when we move up, we got 1 over 2 outside integration sign. And then inside search symbol in denominator, we still have bracket x minus 3 squared minus bracket 5 over 2 squared. Okay. Okay, now we write into the form of a squared and u squared. A is constant. U is term containing x. Okay. So after that, okay, we need to list down what is A. So now our A is 5 over 2 and our U is x minus 3. Okay, after that, we need to differentiate. Okay, when we differentiate U with respect to x, okay, we have 1. Okay, because when we differentiate x, it becomes 1. Okay, when we differentiate negative 3, it becomes 0. So we just write du over dx equals to 1. And after that, we write dx as a subject. So we have dx equals to du. Okay. Then we substitute back. Okay. So after that, we have 1 over 2 outside integration sign. And then 1 over square root of u squared minus a squared du. Okay. We write in terms of a, u, and du. Okay. Our a is 5 over 2 from here. Okay, we replace 5 over 2 by a. Okay, from here. And then we replace x minus 3 by u from here. Okay, and we replace dx by du from here. Okay, and then this formula, okay, is similar to formula number 18 in appendix, because formula number 18, we have integration of 1 over square root of x squared, in between is minus, a squared dx. So x comes first. So from this, we have u come first, and in between is minus, and then a squared. Okay, so similar. But in this appendix, the term is containing x. Okay, and in this question, we have term containing u. Okay, so from this formula, it is equals to inverse cos x over a plus c. So we can write half integration of 1 over square root of u squared minus a squared du equals to 1 over 2 inverse cos x minus 3 over 5 over 2. Okay. Okay, from this formula. Okay. But from here, we have fraction in fraction. Okay. So we need to simplify. Okay. So after we simplify, we can move to, okay, up to numerator here. So the final answer is half inverse cos 2 bracket x minus 3 over 5 plus c. Okay, this is the final answer. Or we can expand to x minus 6. Or we can leave like this. Okay, got it? Coming up next, examples for integration of inverse hyperbolic functions involving completing the squares. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.